Okay, Math 2. Here is your final exam review. I'm going to try and do this in 3 parts so you can work on each page. Remember, the best way to learn is to ask questions in class, get help from me after school or another teacher or a friend or somebody or at lunchtime to work through it yourself and then check your answers this way. This first question is asking, do you understand the relationship between a fraction and an exponent and the roots? So this is the 5th root of a cubed. That's the same thing as, by the way, the 5th root of a to the 3rd power. Either of those things mean this, a to the 3/5. Okay? So 81 to the 3/4 means either 81 cubed the 4th root of that, or the 4th root of 81 to the 3rd power. Now, I like this one because I know that the 4th root of 81 is 3. And the reason I know that is because it's 9 times 9, and 9 is 3 times 3. So 81 is 3 times 3 times 3 times 3. If you're not sure, you can always break a number down like this. Also on your calculators, and I'm going to grab a class calculator. On your calculator, you can see that there's a button that actually says what is x to the 1 over y. So 81 to the 1 over 4 is 3. So anyway, so this means that the 4th root of 81 is 3. So we're saying what is 3 to the 3rd power? 3 to the 3rd power is 27. That's our answer here. If x is 3/2, what is x to the 3/2 if x is to the 2/3 is 16? So we need to figure out what is x, and then we can take that to the 3/2 power. So to find out what x is, we need to say x to the 2/3 equals 16. And let's write this in radical form. The cube root of x squared equals 16. Now, the reason I wrote it this way is that I have a pretty good idea of what squares are. And so if I say something squared is 16, that means that this thing in here must be 4. Right? Something squared is 16. That something must therefore be 4, because 4 squared is 16, excuse me, 16. So now I need to say what is the 3rd root of x is 4. What we're saying is there's some number that when I take the 3rd root of it, and basically I undo the to the 3rd power, I get 4. So what this means is we're saying this number is 4 to the 3rd power, which equals 64. Now, if x equals 64, it's saying what is x to the 3/2? So x to the 3/2, this means x equals 64. This means the square root of x to the 3rd power is 64. So what then is, how can we get closer to x? What x to the 3/2 is? I'm sorry. Let me back this up. X is 64. So we're saying what is x to the 3/2, or what is the square root of x to the 3rd? So this is x is 64 to the 3rd power. So the square root of 64 is 8. So that means 8 to the 3rd is 512. Okay, so your question on the final exam is going to ask you to figure out a fractional exponent where it's not going to be as simple as just, oh, type it into my calculator. So I want you to make sure you're clear. If you represent these things by breaking them up into roots and exponents instead of fractions, it will help you make the connection. about how do we move from the number and figuring out what x is. All right, number 4. Here we have a negative exponent, so this is 12x to the 15 y squared over 6x to the third y to the 6th times 1 over x to the third. So now we have 12 divided by 6 is 2. I've got 15 x's multiplied together on the top, and I've got 3 and 3 down here. So that means altogether I have 9 more x's multiplied together on the top than I do on the bottom. For the y's, however, I have 2 and 6, 2 on the top, 6 on the bottom. That means 2 from each top and bottom will cancel out, and I'm left with 4 y's on the bottom. So here's my final answer. Remember, if I write the expression b to the negative 2/3 in radical form, so I'm going to say b to the negative 2/3 first is 1 over b to the 2/3. Then I'm going to turn the fraction, the denominator, into a root. So this is 1 over cube root of b squared. So that will work. You can also end up with an answer that is the cube root of 1 over b squared. You can also end up with an answer that says 1 over the cube root of b squared. Or you can get the cube root of 1 over b squared. Any of those are the same. Simplify the radical expression. So this would be 2 times 90, which is 3 times 30, which is 3 times 10, which is 2 times 5. So the square root of 180 is 2 times 2, square root of 2 times 2 times 3 times 3 times 5. So I'm just going with all the prime factors that I found here, but putting them in order. That way I can say, oh, this is 2 times 2 is 4, square root of 4. This is 3 times 3, or square root of 9. Here's the oddball out. I can't do anything with that. Square root of 4 is 2. Square root of 9 is 3. Square root of 5 is the square root of 5, because I have no way of simplifying that. So this is 6 times the square root of 5. Next, it's asking me to add these things together. So I'm going to look for like terms, 8x squared and x squared, so this would be 9x squared. 12 and negative 13, so I'm going to have minus 1. And then I've got a y squared and an xy. Well, since those are not like terms, there's nothing I can do except just carry them through and add them on to the end. So plus a negative y squared and plus an 8xy. This one we're subtracting. So I've got 7m minus 6m squared, 7m squared minus 6m squared. I've got 12m plus minus 20x. So even though I'm distributing the negative, I realize that I don't have the same terms, an m and an x. So this is going to be plus 12m minus 20x. Negative 45 minus 17. 45 plus 17 is 62, so it's minus 62 because we're subtracting everything in here. In this case, we've got 2x inches times 8x minus 2.5 inches. So using the distributive property, we've got 16x squared. Make sure you don't drop the squared because it's x times x. And then plus, minus 5x. For something like this, you can also distribute, but it's a lot more complicated because you've got to distribute a binomial here. So this is why the box method is really helpful, because it helps us make sure we don't miss anything. It's important, though, that we remember that if we've got an x and an x, we have to think of this as x to the 1. So this is 2 times 4 is 8. X to the 1 times x squared is x cubed. Minus 6x squared, because I've got x to the 1 and x to the 1. And then plus 14x. Here's 16x squared, 4 times 4 and x squared, minus 12x, and plus 28. Now I'm combining like terms. I see that I have two x squared terms, so I'm going to have 8x cubed plus 10x squared, because I've got 16x squared and minus 6x squared, plus 14 and minus 12, so this is going to be plus 2x, and then plus 28. What is the product of x minus 15x plus 15? So this is a scenario that we say is, this is multiplies into the difference of squares. If you box method this, you'll find that you have x squared negative 225, and then you have minus 15x and plus 15x, and those are going to cancel each other out. So we have x squared minus 225. This is a perfect square, 15 times 15. There's a perfect square, x times x. So we have the difference, a subtraction problem, the difference of squares. To multiply this, we'd say 9 minus x times 9 minus x. 9 times 9 is 81. Minus 9x minus 9x. And negative x times negative x is positive x squared. Make sure you're paying attention to the negatives. So this is going to be x squared minus 9 is minus 18x plus 81. All right, similar ones. I just wanted to give you some additional practice on this, particularly so you can see the pattern here. So I've got a minus 7 squared. This is going to be a squared minus 14a plus 49. Now you say, how did you do that so quickly, Mr. Woodward? Whenever we do a box method and we've got a perfect square, we've got two of the same terms from multiplying the first of one by the last of the other, and the last of one by the first of the other. So it's always going to work out that way because we have a perfect square, exactly the same thing on either sides of the box. So that means over here I'm going to say, well, I'm going to have an a squared, a 7a, a minus 7a, and a minus 7a, and then 7 times 7. The form we give for this is ax squared plus minus or plus 2abx plus b squared. That is what this is called a perfect square trinomial. So if I notice this is a equals 4 and b equals 3, I can use this form and say this is going to be 16x squared, or y squared, plus 12y, so plus 24y. That's the 2ab, and then plus 9. If we look backwards, we can see that this is 9 times 9, and this is 5 times 5. And then I've got 9 times 5 is 45, so sure enough, 2 times 9 times 5 is 90. So this is going to be a perfect square. Is it going to be minus 5 or plus 5? So I know it's plus 5 because I've got a positive 90 here. So that means it's going to be a plus 45x and a plus 45x on my box. So we're looking at this one. All right. If you need to try the unbox method, that would be saying that my product is 6 and my sum is 5. So that's going to be 2 and 3. Notice that if this were a minus, all of a sudden we'd be dealing with a very different kind of problem. Well, not very different, but it would be different because we'd say the product is negative 6. So we could still have a plus 5x, but instead of 2 and 3, positive 2 and positive 3, we would be having a negative 6 and a positive 1. Or excuse me, positive 6 and a negative 1. Right? So if it was minus 6 instead, then we could still factor this. It would just be different roots. So this becomes x plus 2 and x plus 3. This one, I'm just getting you to recognize that when we have a positive at the end, that means that they're the same side, but if they're both subtracting, then it could be x minus 2 and x minus 3. Here we've got factoring. This is a perfect square trinomial because it's 2 times something, and this is that thing squared, so 2 times 4 is 8, and 4 squared is 16. You can also use the box method. You can say, well, my product is going to be 16, my sum is going to be 8. And you'll see that this is 4 and 4. So I have x plus 4 times x plus 4, or x plus 4 squared. All right, fill in the blanks to make a perfect square trinomial. So we're saying x squared minus 12x plus something. What's going to make that a perfect square? Well, remember this is 2abx is what this term is. And we know that a equals 1 because we're going to have an x and an x. So therefore, 2 times 1 times b must equal 12. So b must equal 6. So this is going to be b squared. So it must be 36. Let's see, minus 6 and minus 6. So that's what this would be. 36 is what this is. That's the answer to this, but it would look like this, x minus 6 squared. Okay, same with this one. Because I don't have a leading coefficient, a equals 1, then all I'm doing is dividing by 2 to get b. b equals 13, so b squared equals 169. Okay, solve for the equation. We're going to use the zero product property, right? I've got something times something else equals 0. So this is going to be add 3 to both sides. I get 2x equals 3, so x equals 3 halves. X equals negative 4, because negative 4 plus 4 is 0. So you should have 2 equations like this when you have intercept form or standard form or vertex form. 2 answers. Solve the equation. So here we've got to get back to this form. So you need to figure out how to factor this. Product is going to be negative 60. Sum is going to be negative 4. So product of negative 60 means I know that one of them is negative, so I'm looking for something that multiplies to get 60 that is 4 apart. And that is negative 10 and positive 6. Now, why wouldn't we go negative 6 and positive 10? And the reason is that our sum, our middle term, is negative. So that means we need x minus 10 and x plus 6 so that we have negative 10x and only positive 6x. That's what will help us. All right, so that equals 0. That means x equals 10 or x equals negative 6. Number 23, here is the vertex. So this is the point 0, 4. Here's the zeros. So I've got negative 2 and 2. And so this is, not 0, but negative 2, 0, and 2, 0. All right. So intercept form. Y equals, or f of x equals, here's our intercepts. If the intercepts are negative 2 and 2, that means it's going to be x minus 2 and x plus 2. Notice that this is over and down, so that means over 1 and down 1. So that means my A is negative 1. So I need to have a negative 1 there. I know that because it's going down instead of going up, right? So this is a negative 1, not a positive 1. Normally it would go over 1, up 1, over 2, up 4. Right? But now it's going over 1, down 1. So over 1, down 1. So that means that this has been inverted. It's negative. So this is intercept form. Standard form would be if we multiply this out. So we could say this is negative x squared plus 2x minus 2x minus 4, and sure enough it's a difference of squares, so that it's negative x squared minus 4. There's standard form. We could put standard. We could also put this as x squared, negative x squared plus 0x minus 4. Vertex form is where we take the vertex 0, 4 and we put it into the form. So that means we have f of x equals a 1, a equals 1, excuse me, negative 1 times x, here's our vertex of 0, 4, minus 0 squared plus 4. Make sure you don't forget the squared. So this is the point HK, and remember our vertex form says it'll be y equals a times x minus h plus k. So that means h is what we subtract. Okay, so there's review sheet number 1, and I'll come back and record review sheet number 2.